Good afternoon, everybody. Thanks for dropping in on the stream. So, what I'm going to be doing today is working on some of the reactor systems and where they relate to the cold start tutorial, which I'm just launching in now. Okay, so when the tutorial starts, the whole ship is going to be cold and dark. So we shall go through and slowly get everything up and running. Just making sure I've got all the stream stuff sorted. Hopefully you can see my game screen. Actually, can you just let me know in the chat, one, can you see my screen, and two, can you hear me? And three, is the music too loud? Cool. Okay, so I'm going to ignore the instructions for the minute, because they're wrong. Okay, sure, 1 sec, let me just turn that down a bit. Is that better? So, bug number 1, the reactor's running when it shouldn't be. Let's take a look at that in a sec. So the idea with this is, in order for the reactor to start, when it's not bugged, we need to start supplying power to all the engineering systems, and then we need to start supplying the reactor with its commodities, like coolant and fuel. So this UI is still a work in progress, which is why it all looks messed up. So first thing we do is we connect the start capacitors. And that should give us something. Okay, brilliant, that's broken as well. What a good start. Right, let's go and take a look and find out what's going on with all of that. So at the moment, the reactor code is a little bit all over the place because it's still a work in progress. But generally speaking, let's just grab the UI a sec. So we have power coming into the reactor bus here, and once the bus is powered, then you can start turning on all the various reactor components. And this side just manages the cooling of the coils. So the first thing we need to figure out is, why is the voltage not coming in? So that's the reactor start feed there. And that's the feed supply there. Right, and that needs to be on interface A, not B. Okay, we're good on that side. And we're good on that side. Someone's asking when there'll be an update with aliens. So at the moment, the roadmap, we're finishing the cold start tutorial, which is what this is about. And then after that, we're going to be working on planetary scanning, adding a bit more life to the galaxy, and doing the beginnings of the procedural life generation. So to begin with, we're not going to have physicalized aliens. That will be coming later. We'll just have text-based descriptions when you're scanning worlds, just to outline what sort of life is there, what the algorithm is kicking out for things like temperament and how xenophobic they are and how aggressive they are, what their tech level is, that sort of thing. So we're going to be rolling it out in stages. So every time we iterate on the system, we'll be adding more detail and just fleshing it out more. And then once we've done that initial work on the galaxy for alien life, we'll then be moving back into the ship to start adding role-specific gameplay to make sure that every crew role has at least something to do on the ship. Then after that, we'll go back to the galaxy again. I guess when there's so much in the game, because it's quite wide in its scope, we just have to keep iterating and iterating each thing separately. I guess a bit of a round-robin approach. But first of all, we need to get this tutorial working. So topology-wise, under the floor here, we've got a bunch of startup capacitors, and they are putting their voltage into the reactor so that we can start that up, and that comes out of this cable here. Obviously these aren't routed properly yet, they're just placeholders. And then that should turn on the screen. So let's just make sure that's actually happening a minute. I'm just going to turn on my fan because it's like 1,000,000 degrees here in the UK at the moment. Let me know whether it's interfering with the mic. So we're just entering our 3rd year of development now. Thank you. Yeah, I think we're quietly confident that once it's finished, it'll be a deep and engaging game, and the kind of space exploration game that we've always wanted, and there aren't really any other games out there like it. And we're planning to release it for free. Obviously there needs to be some kind of income stream, so we're going to have various ships and things as DLCs, and single-player campaigns as DLCs as well, to help fund the development. Thomas Grillo, yes, so this is Unreal Engine that I'm working in. So right now I'm playing it within the editor, which is why you've got all the editor stuff around. Yes, the game is currently on Steam. In fact, the demo is available now if you want to check it out. None of this is in the demo yet. This is going to hopefully, if I get it done in time, be updated this week. And as you can see, there's a lot still to do. So if I just give you a demonstration of how this should work. So right now with the coolant loop, for example, we can see the flow rates of the helium, which is cooling down these coils. Now if I run down here, so this is the tank room, or the cryo room, which has all the cryogenics, and this is all the hardware which is pumping all the cryogenics into the tanks. But if we go around here and we just kill this valve, that's basically turning off the helium supply and the coolant. And then we run back to the reactor. You can see here that it's now erroring because we've got no flow on the valves coming into the reactor, and temperature is now too high in the coils to support fusion. It's still running, which it shouldn't be, so I'll get it to actually pay attention to that at some point today. Will the AI be more advanced, such as it actually doing tasks and affecting the ship? Yeah, absolutely. So the AI crew are going to be a big part of the ship. Right now, they're just pottering around, looking at screens, not actually doing anything. But they will actually be performing tasks. So like every single one of these cables will have health and damage and wear and tear, and they'll be spending the majority of their time just performing preventative maintenance on all these cables and things. And obviously if something breaks, they'll go fix it. And they'll be working alongside the player, so the player will have a role in that as well. Thomas Grillo says he's legally blind, and will there be a way to magnify the on-screen displays? Yeah, so you can just hold down the right mouse button and that'll zoom in. If you need it to zoom in more than this, then we can always put that in the settings somewhere, so you can control just how much it zooms. But you can right-click and zoom anywhere. It's definitely needed on some of these displays, because some of them have quite a lot of text on them. Yeah, I doubt this game is going to run on any tablet-like device. And we're using some of the latest tech from Unreal, so right now we've got Nanite enabled, and at some point we'll also be enabling Lumen, so it's not going to work on anything that can't do DirectX Shader Model 6. Right, I just open that valve back up again. Okay, that should restore the helium flow. So you can see here that the helium intake is happy, decent temperature, happy flow rates, but we're still showing a high temperature across the board for the coils and the outflow, and that's because the outflow is obviously being heated up by the coils. So as it cools them down, they'll start to sort themselves out. So you can see the formation coils are now within the good temperature range, and the confinement is now okay. So there we go. So that's all now back to happy operating conditions. And we also have vacuum as well within the reactor. So that's the internal air pressure, which has to go all the way down to 1 nanopascal, which is like practically pure vacuum. I think space is something like 0.001 nanopascals. Okay, so let's just find out what's going on with this. So if we disconnect the reactor feed, all these screens are now off because they're no longer receiving voltage from the reactor. Everything else is powered by the batteries, which are already charged. So that should still be on. Okay. Now if we enable the startup feed, we should go into emergency lighting. Yeah, so that's still working. And you are still on. Okay. And if we turn off these... Okay, it's still on, which is good. Okay, so the issue we're having with this is the screen is not being powered by the reactor room power supply. Okay, so that's going to be a cabling miswire somewhere. Let's see if we can sort that out. So regarding the high temper alert logos, would suggest not overlaying them on the numerical readings. Yeah, I laboured over that for quite a while, and I probably will change that at some point, but for now, it's just the easiest place to put them. We're limited on UI space, especially in the middle here, so finding somewhere sensible to put all the error messaging is a bit of a challenge. But this isn't the final iteration of this UI. It will be iterated on a lot over time, so this will get clearer and more user-friendly. I think most of the UIs in the game have gone through several variations now. Okay, so voltage is coming in. Setting our bus voltage. Right, are we updating the UI? When do you think we'll be starting on the crew quarters? So the next update we do is going to focus on stuff in the galaxy. So more things to explore, more things to discover, just generally more to do in the galaxy itself. Once all that's done, I'm then moving back inside the ship to do ship-based gameplay. So while I'm doing that, I'll flesh out more of the interior, and that'll be a good time to work on the crew quarters and a lot of the other internal spaces, which are just bare framework right now. Okay, so what seems to be happening is this isn't being triggered. Okay, so why are you not being triggered? We're definitely getting voltage in. Right, that would be better off just taking the max float value from that. Oh, everything's lagging. Yeah, because the internal bus voltage should essentially be whatever the highest input voltage is, which for the most part is going to be the reactor itself if it's running. Otherwise, it'll be whatever the external supply is feeding in. Will there be any computer-based mechanics? Yep. So eventually the computer system, it won't be a fully simulated OS, but it will behave like one. I do want to add a scripting language to it, so you'll be able to write some really basic linear scripts for things like, I don't know, initiate red alert, raise the shields, charge the weapons, all in one action via a script. And you'll be able to create those in-game rather than using an external tool. And you'll also have command line interface to all the devices on the ship. So I'm an ex-Cisco engineer, so I'm quite familiar with working with routers and things. So it'll be similar to that. So you'll connect to a device using its device name, and then select whichever interface you're interested in, and then either shut down or change some settings on that interface via the console command while you're sat at the station. Yeah, so everything in the game is based on realistic engineering wherever possible. So the physical construction of the ship is based very much on how we build real world like mega vessels today. So like the biggest cruise liners, for example, they're built using what they call blocks. So they're prefabricated steel structures that get welded together to create the whole ship. And this is very much the same. So like behind the walls here, if I select one, this is an example of one of the blocks. So this would be prefabricated in some factory somewhere, and then this piece as a whole will then be welded into the deck structure. Similar for say this piece here. Again, it's a set piece which is prefabricated and then welded into place. And the whole ship is built this way. It's built with real structural framework, which is all welded together. Yeah, at some point there will be stations. So one of the plans we have for quite far down the line is things like alien derelicts, alien stations, and we want them to be somewhat like an isolated dungeon in space. So you'll breach whatever that item is, you'll work through it on foot, maybe have to solve some puzzles to get to whatever the end point is in that, and there'll be some kind of loot or reward in there, a new bit of tech, for example, for the ship. And that aside, there'll probably be friendly alien stations as well. With this ship being the first ever human deep space exploration ship, there isn't going to be human civilization out there in space. So we haven't colonized the galaxy at all yet. There'll probably be some bits and pieces around Alpha Centauri, or maybe a couple of the closest stars to Earth. But beyond that, nothing. It's all just alien space. We haven't been there yet. Yeah, alien fleets. Again, somewhat down the line. But Unreal has got some really robust tools now for simulating like crowds and things. So we can potentially have a lot of ships moving around the galaxy at once. The third DLC we're planning is going to have an element of colonization in it, but predominantly this is a space-based spaceship game, not a ground colony building game. So unlike, I don't know, Starfield or No Man's Sky, I doubt we'll ever get to the point where we're building surface bases, as a player settlement, because that's really not what the game's about. The game's about exploring space. The DLCs won't be free. There'll be single-player campaigns, and they'll be a lot more expensive to produce because we'll have to pay things like voice actors, and we'll need a much bigger team for that sort of thing. Right now, it's just me building this stuff, so obviously we need to expand the team, employ more people, and we can't do that for free. Price-wise, yeah, I imagine the DLCs are going to be sort of typical indie prices. Yeah, about that. Yeah, $20, $30, something like that. It won't be AAA prices. The same with the ships. So when we release a lot of smaller ships, because we want, as much as we've got the big Magellan class, 200 crew, huge ship, we also want to release much smaller ships, sort of Firefly, Millennium Falcon type ships, where maybe 5 people in a multiplayer crew can do everything as a team on that ship, rather than having to rely on hundreds of crew members. And yeah, price-wise, they're going to be in the region of $10 to $20, I expect. Again, it's just we need, because we're planning to give the game away for free, we need some kind of an income stream to expand the team and actually bring on more developers. I want a team of developers doing nothing but producing content for the Galaxy, for example. Yeah, I am the only developer. It's just me. Obviously, I've got my partner Claire. She handles a lot of the business side of things. She handles the social media and the marketing. We've got a guy called Jose, which does some of the audio work for us, and there'll be a lot more from him coming soon. And we've also got our composer Eric, who does some of the music for us. Right, so what are we doing? Right, figuring out why this isn't working. Okay, so this is good. We're taking the maximum any of our input voltages, and if any of them are over 0, we turn on the UI. So that's fine, nothing wrong with that. I think the issue is with what's happening here. So this one should have a cable coming from over here, because it should be connected to that. Which I'm assuming actually would have been this that I turned off. Yeah, I think releases every 2 to 3 months is pretty accurate. And we put the demo out about 2.5 months ago, or thereabouts, and we're pretty much ready for the next update now. So yeah, I think every 2 to 3 months is pretty much it. I think moving forward, I'm probably going to sort of settle into a quarterly release cycle. So 4 major updates per year, and then between times we'll have just bug fixes and things. Let's set this one back to interface B. So all that was doing is just showing the UI. What it should be doing is that as well. And in fact, no, we don't want... Okay, so as far as the UI is concerned, we only want the UI to be powered by the rooms supply. We don't want it adding that to the reactor main bus, because then it will start trying to draw the reactor feed from the room supply, which will just blow everything up, so we don't want that. So ideally we need a separate bus, which means that actually that does definitely need to be interface A. So on the bridge, I just fly up. This seat here is going to be the comms station. There'll be a lot of comms-based gameplay at some point. Obviously, we need to hail other alien races, so that's where all that will take place. And over this side, you'll have tactical one side and defences on the other. And in the alcoves here, you have a couple of engineering stations on that side. And on this side, you'll have environmental control and internal security, as well as like a weapons locker on here. I think we worked out there's 8 bridge stations. 1, 2, 3, 4, 5, 6, 7, 11. Yeah, 11 bridge stations in total. Yeah, so it's going to be tremendously difficult to bring on additional developers. Not so much for working on systems and things, because they're pretty generic, but when it comes to the design of the ships and, you know, just generally working on the interiors, I think that's where I'm going to get quite OCD with people. Because I have like this design vision for the ship. So I think the way I'll probably handle additional developers is I'll give them a ship to work on, so we'll have multiple ships in progress at once. Thanks, Young, I appreciate that. Alien languages, we're probably going to use some procedural sort of text letter swapping for the most part, just to handle the fact that you can't understand that language. And then as you understand that language more, then you'll be able to unravel those words so that the gobbledygook letters will start to form actual words. And the way that you'll do that is you'll train the ship's computer on what those languages are. So you'll need to gather artifacts from the planet's surface, like pottery and other sorts of stuff. And then in the labs on the ship, that will be scanned in the linguistics lab. And then the more artifacts of that race that you put in the linguistics lab, the more you'll be able to understand their language. And we'll have that as a bit of a precursor to communicating with other races, unless they're advanced enough that they can send you their language database. So it'll be a relative tech level based thing. Yeah, we've got a fair load of internal design docs, which are just internal for now. But you know, once we start publishing more robust roadmaps and things, it'll all be on there. I think the problem we've had with roadmaps up till now is that I tend to sort of work on downtime. So I'll think, yeah, that'll just take a couple of weeks, and then a month later, I'm still halfway through it. So we're kind of leaning away from adding timescales to roadmaps and just kind of focusing on what features we're planning to do next instead. Let's see, are we actually getting that UI update? So that would be that. Okay, so we're only updating the errors on it, not the actual value. So that one's the fluid UIs. Do we have an electrical UI? Right, here we are. So it's that one, that's that one. Ah, yeah. When it comes to taking on new people, we'll have a bit of a design bible, I guess. Detailing the design language of various organizations within the game. Obviously, right now we've only got a UN ship, and that has a design language. But you'd expect all UN ships to have a similar design language. And when it comes to other manufacturers within the game, they'll have their own design language. So we'll have some, grungy, overly metal ones, and then we'll have more luxury-based ones and such. A bit like Star Citizen, I guess, in that regard. Like if you look at the Origin ships in Star Citizen, they all have that same design language and feel about them. So we'll be doing a similar thing here. I shall tidy this up later, just going to make sure it actually works. Actually, on that note, we also need that one. So all we're essentially doing with this is we're just updating the stat boxes on the UIs. We're using blueprint interfaces just to send the messages across, and then we switch on the interface description. So if we give it the description reactor bus, it'll choose this one and send the data to that UI element. So that's what gets fired when the replication happens. The deciphering of alien languages, it's not really code breaking, it's more having a saturation of examples of that language for the computer to be able to work it out. If you look at the state of AI these days, AI is already getting incredibly capable. We're very close to the AI singularity already, and this game is set 200 years from now. So who knows how good AI is going to be in 200 years. Realistically, it could probably run the whole ship itself without even needing a crew, but that's no fun. So we will limit the scope of what the AI can do, but within the confines of the game, the idea is that you just feed the AI with examples of the alien language, and then it will be able to then translate it for you. Yeah, so you give the AI the ship's AI the puzzle pieces, and it finishes the puzzle for you. And that's what the linguistics lab on the ship will be for. So you'll have physical examples of that alien language that you take to the lab, and then the equipment in the lab scans it, and that's what adds up the percentages of how much you know that language. So you just keep firing examples at it until the ship goes, yep, okay, I understand that culture now you can speak to them. And then the ship's computer will handle the translation when you hail them and speak to them. Let's just make sure we're getting some voltage readings on those UIs. Yeah, so a broken piece of pottery is not going to be as useful as a book. And again, if it's an advanced spacefaring species, you'll be able to receive their language database, wholesale, and you won't need to go through the effort of actually physically translating their language, because they'll just send you their language. Yeah, eating will be a part of the game. Not a huge part of the game. We don't want it to become, annoying. But there will be survival elements to it. So the ship will need clean air. The crew will need to be fed and watered, but not excessively so. Sort of survival light. So we're getting some data there, although it is reading zeros. It's not very helpful. I'd say Star Trek is an inspiration. It's not the inspiration. Obviously we have history, working on Star Trek stuff. But we've also worked on and with the Orville a lot, and I think my personal favorite sci-fi of all time is actually Babylon 5. So a lot of the alien life in the game is going to be more Babylon 5-esque than Star Trek-esque. But there's loads of space sci-fis that we all love, so it's going to take inspiration from all of them. It won't be. It's not taking its inspiration from one specific thing. It's really just across the board. Space sci-fi good. Take good ideas from all of them. Yeah, the second DLC is going to be a lot more combat focused, and in fact the main ship on the second DLC is planned to be a carrier class vessel with a complement of fighters, and that particular DLC is going to have a much more Star Wars feel about it than the first DLC, which is going to have more of a Trekkie feel to it, and then the third DLC is going to have more of a Firefly feel to it. So we're not sticking to a single genre like that. It's not a specific Star Trek, just Star Wars rather, not a specific one, just Star Wars in general. Star Wars is a lot more, well, I guess the clue's in the name, war. It's a lot more militaristic. So yeah, lots of shooting and blowing stuff up. Whereas the first DLC is a lot more about diplomacy and exploration. Actually, I've just thought of something. That interface wasn't on, so it wouldn't receive voltage. Okay, still no volts. Are we getting any volts on this side? Cable definitely has load on it. That's better. Okay. Reactor really wants to stay on for some reason. Yeah, when it comes to the single player campaigns, we want each one to feel very unique and very different. So like I said, the first one's all about diplomacy and exploration. Second one's all about shooting stuff. Third one is essentially cops and robbers in space. And the fourth one is either going to be something silly, like a cruise liner, sort of inspired by The Fifth Element, or the other series, which I now forget the name of. Yeah, either something like that, sort of almost a comedy-based cruise liner one, or something more kind of, you're stuck thousands of light years away from Earth and you have to find your way back kind of story. Oh, that's it, Avenue 5. Yeah, thank you. Yeah, I think an Avenue 5 / Fifth Element style, having to manage a cruise liner with loads of passengers and lots of different needs and things could be a breath of fresh air to the serious sci-fi that we're trying to do generally. But obviously that's 4 DLCs down the line, so we're talking many years before we get to that. Okay, so something we need to add to this is the actual draw on the bus, which is what's going to come from the actual internal fusion reaction itself. So that needs to be drawing on this. I shall get to that in a bit. Okay, so we should at least see some voltage happening there. so we're getting 100 megawatts voltage. Should be same there. Okay. That's fine, but there's no load yet because we're not actually simulating that. That's fine, and that will drive the amperage as well. So the breaker on the reactor is going to be a 5,000 amp breaker. So we just need to make sure that we don't draw more than 5,000 amps on it, and that should all work for the whole ship. Right, now we just need to get that one hooked up. So the fact that that's reading 0 volts right now is fine, because that's only used during the startup. Once the reactor's running, that's not needed anymore. But this one should always be showing voltage. So let's just have a look. Fuel modelling. I will show you in a sec how that works. In fact, it's probably easier if I do it whilst flying around. So, at the very, very front of the ship, which is kind of here. So this is the front of G-Deck. So this is the outer hull here. So you can't see, but that's basically the outside of the ship. This is going to have fuel scooping hardware, essentially gas collection hardware. And the gas collection is going to have multiple channels which are tuned to different types of elements. So, helium, helium-3, deuterium. And the hardware that scoops that up will freeze that down to a cryogenic fluid. And that will then be piped along these pipes here. So right now we've just got these fake fluid sources. And these fake fluid sources will be replaced by the actual hardware that's there at some point. They get pumped through the wall into these pipes here. So we've got helium-3 in this instance, and the other one's helium. And that gets piped up there, over the top, and it goes into these cryocoolers. So in here you've got the big pipes are the refill pipes that come from the collection hardware, and the smaller ones are just return pipes. One of them's from the overflow, the other one's from the reactor. And then this gets pumped into the tank, which is what this is here. So essentially what you're doing is collecting gas from gas giants. So the refueling mechanic in the game will be skimming the upper atmosphere of gas giants, and we want that to be fully volumetric, so you're literally skimming the upper cloud layers, and that all gets put through this hardware into these tanks. Initially these were going to be Stirling cryocoolers, which is why they look like Stirling cryocoolers, but since then I've learned about magnetic refrigeration, which is a much more exciting tech. Essentially you have these, I think they're called magnetocalorific materials, and if you apply and then remove a magnetic field, they heat up and cool down. So these cylinders have got essentially a spinning magnet, and as the magnetic field is added and removed rapidly from this material, it creates these cryogenic temperatures, and you can get much lower cryogenic temperatures with that as well. And on this side, this is where the pump hardware will be, which I have not modelled yet. And essentially the pump hardware just pulls the fluid from the tanks, runs under the floor here, under the floor here, under the floor here, and then pops up into the reactor, and then the same on the other side. And that's essentially the fluid loop. Today I am working on the reactor, so essentially the reactor UI is pretty much finished. Got too many tabs open, let me get some of this unneeded stuff a minute. No, finished with that. Finish with that. Don't need that. Don't need that. Might come back to that one in a minute. Yeah, so the UI for the reactor has everything on it needs. I'm just doing the final touches and making sure that everything's flowing through it properly. The fluid side is all done, it's all working well. This bit's working, that bit's working. The vacuum side's all working. I've got a couple of things to add here with the flow rates. The electrical draw and output need to be sorted out. And then just need to make sure that the electrical side here is all reporting its values properly. And then really the last thing to do on the reactor is to just add electrical usage. So right now we're generating voltage, but we're not generating any draw. So that fusion reaction obviously needs to be significant wattage draw just to maintain the fusion reaction. And that needs to be deducted from the total output of the reactor. But I shall get to that and balance that once all these UIs are working. There will definitely be pets. Well, the ship's going to have a dog and a cat on it, and a chicken, obviously. We've got Admiral Cluck Norris, who is wandering around the ship at all times. There'll also be a dog called Buster, named after Claire's dog, and a cat, which I'll probably call Sooty, named after my original cat. So they'll just be roaming the ship as ship's pets. And this is an interesting one because I have debated this with Claire quite a few times on the moral side of keeping an alien creature as a pet. So let's say you rock up to an alien planet and it's an ocean world, and you send a probe down, you retrieve a measure of fluid with some alien fish in it, and now that fish lives on your desk. So, morally, we shouldn't be doing that because that poor fish needs to live in its natural environment. But then, people want pets in the game, so there's a bit of a debate going on there. I guess the balance is, do we want to make something fun, or do we want to make it a moral lesson that humanity shouldn't be retrieving creatures from alien worlds and keeping them as pets? Perhaps we'll have a middle ground where we just give them really nice habitats and they don't realise. Yeah, so the ship won't have a prime directive. Again, that's a Star Trek thing, and we're not... If it's a Star Trek proprietary thing, or a proprietary thing in any of the big sci-fi shows, we won't be using it because obviously there's copyright concerns there, and we can't just use these ideas as cool as they might be. So, we're not going to have a prime directive. However, there will be some standing orders, so they're not going to be as strict as Star Trek's version of the prime directive. It's more a case of do no harm. Don't be, a space troll. But if you see an alien race in distress, go help them. There's no prime directive saying no, don't help them. That's wrong. So, yeah, human nature. If you see something in distress, you're going to try and help it. It's just what you do. Chris is asking about missions. So in the sandbox version, so the free version we're putting on Steam is essentially the sandbox. So that's the whole galaxy and all the procedural stuff. The mission there's one main mission, which is to go out, explore, make successful first contacts, and then bring everyone back home to Earth in one piece. And we'll have some kind of score or rating system based on how far you explore, how much you explore, how much science you do, how many successful contacts you make. So all of that will be your final score for that overall mission. So when you return home to Earth, that's essentially you handing in that mission. So the idea is the longer you stay away from Earth, the more you put the ship at risk, and the more exploring you do, the higher your overall rating will be. And then you'll get to then do that again with the same ship and crew, or however many crew you had left, plus anyone you replace from Earth. And then you can send that same ship and crew on multiple missions. But whilst you're doing that, the alien races that you encounter, in order to achieve successful first contact, they might want you to do something like ferry someone somewhere, or retrieve something for them, or they need medical supplies, so you can go and give them medical supplies, and that'll help you establish that friendly first contact. So in the sandbox, they're all going to be procedurally generated tasks, essentially, which is given to the ship as a whole. So that's how the ship's missions will work. But on a smaller scale, your individual role aboard the ship will have its own to-do list as well. So each department on the ship will have essentially a jobs board. And you, along with the NPC crew in that department, will be working off of that jobs board. So if we take engineering, for example, the most critically damaged and worn out components will be the things at the top of the job board. So the NPC crew will just work from the top of the list and work down. And then you as the player can also either get assigned or choose to pick these tasks off of the job board and go complete those tasks. So things to do on the ship will be in addition to the overall ship's mission, if that makes sense. Essentially, there should always be something to do. Will there be missions of mercy? Yeah, there'll be anything we can think of, really. With it being a procedural system, I guess the beauty, but also the challenge of a procedural system is you need to make sure there's a lot of variety in there. So as many different types of missions as we can think of all need to be sort of plumbed into the procedural algorithm. So the thing that it eventually spits out as a mission is different from the last one you did. And yeah, so it could be something like you rock up to an alien planet, and there could be two main factions on that planet, and they're at war, and you can speak to both of them, but they're both at war with one another, and you kind of, through no fault of your own, you're kind of forced to either pick sides or just leave. And if you decide to support one side over the other, based on whatever it is they say to you, you might prefer their position over the other one, then there'll be consequences on making that decision. So there doesn't necessarily need to be a right or wrong answer there, but there do need to be some form of consequences. Like, if you support the wrong side from a certain perspective, it could lead to the genocide of the other side of the planet, and then you're like, whoops, made the wrong choice there. But things like that. That's the kind of I guess consequences and cause and effect we want to try and get into the game. Yeah, and so all of the conversations that you'll be having with the aliens will be multiple choice. So the holo display in the center of the bridge will be your main way of speaking to them, and that's going to depend on their level of tech. So if they are a highly advanced futuristic technology people, then you'll have like a three-dimensional Head and Shoulders, like a big floating head to speak to. If they are, say, our level of technology as we are today, you might just have a nice big color 2D floaty screen. If they are even older technology-wise, you might have a black and white screen with a black and white image because they don't have the ability to send color. And then if they're even older than that and they only have radio, then you won't have an image, you'll just have the text. So I like that approach of changing how you speak to them being based on how technologically advanced they are, right up to the point where they'll have a hologram on the ship walking around standing next to you, bypassing your comm system entirely. But yeah, essentially it's all going to be multiple choice, and that's where the diplomacy gameplay is going to come into it, because you'll have to try and judge their current mental state based on their responses and try and pick the right response. Chris asks, if you're down in engineering or something, will you have any insight into what's going on the bridge during these missions and alien conversations? No, essentially. It's a difficult one because obviously it is a big ship and people are working in different departments. So if a conversation is being held on the bridge, then if you're not on the bridge, you'll have no knowledge that that's even happening. There will be events like if the ship goes to warp, for example, that will be broadcast ship-wide, so everyone will know that that's happening. But yeah, so if something's happening on the bridge, you'll need to be on the bridge to be aware of it happening. Although there will be things like engineering stations on the bridge, so we don't want to force, like the chief engineer, for example. If you're playing as the chief engineer, we're not going to force you to be in engineering the whole time, because high-level engineering stuff will be doable from the bridge. But when it comes to the really sort of fine detail, opening and closing of valves, that's when you'll physically need to go down to engineering, or to physically fix something. Obviously, you need to be standing in front of it. Performance-wise, we're still okay. So I get anywhere between, I guess, 70 to 100 plus FPS on my 2080 Ti. Claire's got a 3050, and she generally averages around about 60 FPS on hers. That's on full graphics. Our minimum spec, we're aiming for a 1050 Ti. But as we enable more and more of UE5's next-gen features, obviously, the system requirements go up with it. So as of the next build, in fact, we're ending support for DirectX 11, which is inevitable because a lot of UE5's features just don't support DirectX 11 anymore. They need shader model 6, which is DirectX 12 only. Yeah, so the conference room, the big screen in the conference room will be used for various things. So we'll have it as the mission screen, so you'll be able to see a summary of the ship's missions, not individual people missions on the ship, but the actual ship as a whole. And you'll also be able to pull up the crew roster and various other bits and pieces. Maybe pull up a list of things you visited and just things like that. I'm not sure what you mean by will there be a fog of war. You won't know what's there until you go there. I guess that counts as a fog of war. The further you are from a star system, the less you will know about it. So you're not going to know about what's on a planet's surface until you're in orbit of that planet. If you take an Earth-like as an example, so from outside of the star system, say a light year away, you'll see that it's a rocky planet, and you'll see that it has an atmosphere, and you'll see that it's within the habitable zone, but you won't know that it's an Earth-like until you enter that system and perform a scan within the system itself, and now you know it's an Earth-like. But then you don't know if it's got life on it yet until you actually go over to it and have a look. So there'll be like a staged approach to gaining knowledge about astronomical bodies. We are going to implement VR. I don't know whether the Quest is going to be able to run it natively. My gut feeling is it won't, because it's based on mobile tech, as far as I'm aware. I don't know. I think with it using next-gen UE5 features, I don't think the Quest is going to run it natively. Even desktop VR is going to require a fairly beefy graphics card. Especially if we turn Lumen on, which we will be at some point. Right, where was I? Yeah, so we need to report on the cable voltage. So that comes from here, essentially. So the cables send out data to the device that's connected at either end, basically reporting things like their current load, current voltage, etc., etc. So we need to sort of intercept that and use that to drive the UI display. So cable 2 does not exist anymore, so we don't need that one. The UI has been both simplified and more complicated at the same time, just to confuse myself. So it's that one that we're interested in. So right now we're not actually updating the UI, so that'll be why nothing is showing. So we want that, and we want to update the electrical UI. Should be that one. It's interface 1, and then we want interface 1. We want to take the load and the voltage. Are we not getting that? No. Right, so I need to add that to the load report as well. The way the electrical UIs used to work is that you'd have, I suppose, like these ones. So you've got the information about that actual cable on the breaker screen. And that's a little bit misleading because it doesn't actually show you the voltage either side of the switch, which is tripped me up a few times now. So what I've done is I've separated it out. So now, let me just show you on that version of it so it's not all messed up. So the cable will report back its condition, and that's what gets updated there, same with that one. And then the reactor bus and the internal bus on all the devices will show what's actually happening internally to the device, which before we didn't have that information. So now it makes a lot more sense. So you can see where voltage is stopping, where it's dropping down, where the load's actually accumulating, and such. Can you land on planets? Not yet. So planetary landings is something we have planned probably several updates from now. In fact, I might make that the thing we work on next after we've done more of the internals of the ship. The way we're going to handle that is you'll have to park the ship in orbit, go down to the shuttle bay, grab a shuttle, and then fly that down to what will essentially be a boundary point, a certain altitude above the planet. And then once you hit that boundary point, there'll be a brief transition where it teleports you and everything to a surface environment. So still in the air, so you'll still be able to fly around the surface, but we need to manage that transition between the space environment and the surface environment. So we won't be able to achieve real time all the way to the surface. Hopefully, that will be the only transition we need to use. And the reason we need to do that is because we move space around the ship. So the ship itself isn't moving, or rather the ship interior isn't moving. Because the ship interior it's made up of many thousands of objects, loads of physics going on, and you can't just move all that at once in a sensible way. So we move space around the ship instead to create the illusion of spaceflight. But because of that, it means the planets themselves are moving and getting chucked about. So we can't have a planet with trees and grass and rivers moving in space, because again, that's just too much stuff to move around. So from orbit, you'll see the detailed surface, and we might even go as far as actually having like models of forests as a solid object that you can see from orbit. But they won't actually be forests until you make the surface transition. And from an engine level, there's also some other complications as well. So the direction light that we use for stars and things behaves differently if you're using it properly with an atmosphere system. So that the angle of the lights will simulate things like sunset, and you can't use that in space because obviously as you fly around, the star changes color as you move around, and it just looks weird. So we need to keep the space environments and the surface environments separate, and that really frees us up to use like the entirety of UE5's feature set on the surface environment with the fogging and proper atmospheres, proper cloud system, or volumetric everything. And ultimately, it is going to be a lot more, I guess, detailed. You have a much more detailed surfaces by separating them out. So there will be a transition, and sadly, it's inevitable. Yeah, I thought of using the cloud layer. So as you approach the planet, it gets cloudier and cloudier, and then that hides the transition point, and then the clouds clear, and now you're over the surface, which works fine for atmospheric worlds, but not so much for moons and things. So I imagine what we'll probably do is, as you hit the transition points at whatever the altitude we define it as, you'll kind of have a third-person view of the shuttle flying off down towards the surface whilst the load happens. And then once the load is complete, you'll be back in the shuttle again. Yeah, so the demo right now is literally just a tech demo. So it's an example of how the game will work and how it will achieve all the things we want to achieve. It's essentially a proof of concept that we can do what we want to do. So you can explore the galaxy on a massive starship. That's we've proved it's possible. The tech demo shows that. So now the next step is to start adding all the gameplay that goes with that. Right, let's get this updated. So that needs to be... So we're updating the error box there. We're updating this display there. So that's all hooked up. That should all be fine. Yeah, and then we're just giving it wattage there. And then we need to also capture the voltage on that as well. So I need to add voltage to the load reports. Might as well do that while I'm here actually. So on the load report we need to add voltage. And obviously, using things like Ohm's law, we can use math to work out things like amperage from that. Now, has stock UE been sufficient so far? Yeah, I'd say for the most part. We're still using the stock engine version, and we don't want to go down the road of using a custom engine version if we can help it, because it just makes it so much easier to upgrade if you're not having to deal with a custom engine. But yeah, so far, I think the biggest change that made what we're doing possible is UE5's large world coordinates and having 64-bit floats. Because when we were limited to 32-bit floats in UE4, that really limited the size of the galaxy and what we could achieve. But with UE5, that's really kind of unlocked the door for everything we want to do, especially with things like nanites, when poly count is slowly becoming irrelevant. And the other thing with nanite actually is it also ups the object count that's possible, so things like draw calls are reduced. Yeah, I think if there's anything that's currently limiting in what Unreal can do, it's lack of directional gravity. So you can't have like a spherical gravity source, so you can't have a planet and walk upside down on it. The stock UE can't do that, so we're having to use plugins to achieve that kind of thing. But yeah, other than that, I think we're pretty much stock. Hendra asks, anyone know why meshes like lamps behind an object still affect rendering cost? If that lamp is using a standard UE light source, then they are not culled, visibility culled in any way. They only get culled based on screen size. So if you were to have 50 lights behind a wall, those lights are still affecting the rendering cost, even though you can't see them. I've actually written my own system to fix that. So this ship has thousands of lights. Like every single one of these is a separate light, and then they have these visibility spheres, which is what this sphere is, and that's equal to the attenuation radius of the light source. So as soon as we go like over here, because you can no longer see the attenuation sphere, that light is disabled, which essentially has the effect of adding culling to lights. That's all you can do, really. You just need to add culling So simplistically, it's doing a was recently rendered check on this sphere, and then if that returns false, then you turn off the light. Yeah, I've yet to find out a reason for why UE doesn't automatically visibility cull light sources, but it hasn't done ever, and I can't find a reason why. I'm sure there's probably a technical reason why they don't, but it seems really obvious to me. If you can't see the attenuation radius, then the light should not be rendering. It seems like a no-brainer, but that's not how it works, so we had to implement our own solution. I've only watched videos on nanite landscapes in 5.3. From what I understand, they are more performant, obviously, because it's using nanite geometry now. Using displacement shouldn't up the rendering cost if it's nanite. I'm still waiting for a few plugins to update before I move to 5.3 though, so we're still using 5.2 here. Hey Cliff, thanks. So I didn't start the Enterprise D Stage 9 sim. I was a developer on it in the past 6 months, I think it was. So I joined the Stage 9 team, it was around about 6 months before we got the C&D, which was really frustrating. So I didn't really get to work on it a great deal. Mostly I was working on spline corridor systems to help flesh out the decks a lot more quicker. And then after that I went on and co-founded Messy Desk with the Stage 9 team, and we did the Orville for a couple of years, and then the urge to do this was so great that I went solo and then did this. I guess this is the game I've always wanted to play. You know, I've always wanted a game where you could properly explore the galaxy. You know, I've messed about in things like Space Engine, and you know, I want to properly explore that on a proper starship and really see what's out there. So you know, that's what this game's all about. Did that crash? That's the question. That was weird. So why is that still not updating? Right, so we're setting our load there, and then that's updating interface 1 there, which would be this here, which is that one there, which corresponds to that one there. So does that therefore mean that we're not actually receiving anything? Let's get rid of that a sec. It used to be the case that when you typed print, oh, look at that, I haven't got context sensitive turned on. There we go, that's better. Thought I was going mad then. Actually, let's make that last for a while. And while we're at it, let's just turn off that. I do all of it, Cliff. So I do the graphics, the coding, the modeling, everything really. I didn't do the music, that was done by our composer Eric, and I've only done about half of the internal sounds. The rest is done by our audio guy Jose. It's quite frustrating for Jose actually, because you know, he's done a lot of sounds that haven't been implemented yet. As you've probably noticed, the ship's quite quiet. You know, if you like pick something up and chuck it, it doesn't make a noise. But that will all be added. There are so many things on the to-do list, it's just a case of working through them. Okay, so we're not getting any spam from that interface. Hooked up. Okay. Let's just switch to that mode a sec. Hendra asks what source control works better for Unreal. We use GitLab, although I do it manually outside of Unreal. I did have source control turned on, but I have all kinds of problems with it and it just doesn't sync. So I just use GitLab separately. I think I'm using, was it Git extensions? I think it was Git extensions I was using. But yeah, I do it outside of Unreal. Glenn asks, is there actual coding to create this or just node connections interfaces? Yeah, so the bulk of the game is made with nodes. You can do practically everything really with blueprints. You know, if you're dealing with things that tick or things that are happening in real time, then blueprints are a lot slower than writing native C++, but blueprints are essentially a visual front end for the underlying C++ code. So things like that is a visual representation of the C++ function. You used to be able to nativize the code, but that's been removed now. But at some point, this will be converted to C++ for performance reasons, because it is quicker. But for now, while we're building it and while we're prototyping, and as we're rapidly iterating, it's quicker and easier just to use blueprints. And then where it's needed, we'll go back and optimize with C++. A lot of the optimization code will be done that way, especially when it like the lights, for example. So the lights are using timers to check whether or not they're visible, and that's the kind of thing that would work much better as a C++ function. Yeah, the UI screens look terrible because if we look at this one here, so essentially I've put together these little mini elements where you can select what type of wire it is, whether it's vertical, horizontal, curve, etc. So it allows me to rapidly prototype UIs, which is good, but for some reason even though it's done pre-construct, that doesn't actually register in the game world until you hit begin play. So within the editor, it doesn't actually update. So while it's updating here, actually editing the widget, it doesn't update in the world, which is probably a bug. So yeah, these UIs look absolutely terrible until you hit begin play. Actually, something I just want to check. So the reactor is definitely using that cable, otherwise the light wouldn't be on. I might go ahead actually and just add some reporting on this screen, because that would help know what's going on with it. Because that cable is this. So feed reactor supply, that's you, so you are feed reactor supply. So we're definitely getting voltage, because otherwise these screens would be off. So if I turn that off, they go off. So that cable definitely has voltage on it, and then that ends up getting supplied over there. Right, so these are seeing 1 kilovolts. So that's all as expected. So it should be reporting that backwards as well. Let's have a look at what the cable's actually doing. Yeah, so that's all the spline stuff, which we don't need to worry about for this. Again, please excuse my somewhat messy blueprints. This is all just prototyping for now. And creating pretty sparkles is what we do when the cable breaks. Right, so we get a voltage delivery. So then we store cable voltage. That's what controls the lights. And then we send that voltage downstream, which is this. We add a slight delay because we don't want all the cables updating at once, because that will create hitching in the game. Deliver the voltage. Deliver voltage to any connected devices. Yep, that's all fine. And then the load report goes in the opposite direction. So actually what we're not doing on the cable is we're not actually sending a load report. We are simply passing it on. The reactor fuses deuterium and helium-3 because it is an aneutronic reaction. It doesn't produce any harmful neutron radiation. Well, theoretically. Thank you, Komi. Yeah, this is about 3 years worth of work now. A lot of these systems, like the electrical system, for example, I haven't worked on it directly in quite a while, so I kind of forget what I did the first time around. Luckily, I did comment everything, so it's quite easy to kind of trigger my memory as to what I did last time. So the way it should work is it simulates an electrical system as deeply as we can without getting down to sort of quantum physics level of simulation. So it uses the voltage and the resistance to define the wattage, and it uses equivalent resistance in instances where you have multiple things connecting to the same bus. So it does perform all those calculations, and the cables essentially just pass that information along. They will also have a damage component to them as well, so the more worn out the cable it is, the higher resistance it'll apply, and therefore the higher wattage, so the higher amperage rather, it will generate. And that will drive heating and cable breakage and that sort of thing. But then it also should be sending a load report, which is this here. That's weird. Why is it not finding that? So that one's sending the voltage. And that one's sending load. Oh, why didn't it find that? It's behaving weirdly. So the load report is being made by the downstream device, sending the load report backwards. So when... Well, that's weird. because the reactor is putting voltage into this cable, which means that it is updating the cable load, which means that it is sending that, which means it is sending that on to the reactor. Unless I've done that wrong on the cable. Let's have a quick look. So that should be connected to interface 1 on the reactor, which it isn't. That's the problem, I think. So the upstream interface is interface 1 on the reactor, which goes to interface B. So when I first started doing this, I used alphabet for inbound and numerical for outbound. And I don't know why I did that, because I'm only using a string, so I could have literally typed anything there and made it slightly more sensible, but that's kind of the naming convention I went with, and I'm sort of stuck with it now. Right, so that should theoretically mean that that interface should now be receiving some data. Yeah, so all the inbound stuff is ABCD, and all the outbound stuff is 1, 2, 3, 4. But when you're dealing with upstream and downstream, it kind of gets confusing, because you're sending up the cable back in to where it came from. So you're sending in to the out. Oh look, there we go. Now it's working. Cable, be happy. Yeah, essentially it was telling the reactor in the wrong interface. So now, there we go. So now we've got 1.2 megawatts of load on that cable, which is what we were expecting. I guess that's an example of how bloody confusing this is getting now, because one typo on one cable literally stops it from working. So there's a lot of just sanity checking that's needed just to make sure that it's all set up properly. And the good thing is it only needs to be done once, because once it's set up, it's set up. But yeah, there's, I think it was something in the region of 700 and something cables on the ship at the last count. So there's a lot of interfaces to get right. Yeah, the reason it's showing no voltage is because we're not actually reporting that value. And what I actually need to do, which I might go ahead and do, is use the same method that I used for the fluid system. And on the fluid system, we're actually throwing around some structs. So, like on these pipes, for example, unlike the cables, we're sending a struct. So it's essentially a packet of data, and that contains all the information we need to know about the fluid within that cable. We can do things like, so we take the amount of volume that's entering the pipe, we're deducting anything that we use from it and adding it to the used volume. So by the end of the run, we know how much fluid we actually used, and then how much is left in the pipe afterwards, taking account for things like leakage. Which is great, because they're structs, it means we're handling all of the data in one data packet that we can just add extra things to if needed. Whereas with the cables, we're actually just adding outputs and inputs on the blueprint interface rather than keeping it all nicely packaged. So really that needs to be updated to use structs instead. because what we're not doing is updating the voltage. So we're using rep notify on a single float variable, and if that were a struct variable instead, we can contain a lot more information within that single rep notify, which is it just makes so much more sense to do it that way. And which is why I changed to that methodology for the pipes. But I made the cables probably well over a year ago now, so I've learned since then. But that having been said, could just convert this to a struct just for the cable component of it. Hi Grabo, good to see you. You know what, let's do that. Let's make us a struct. Unless I have one already. No. So we need a struct. So this is going to be struct, and we'll call it a electrical packet. And then within the electrical packet, we need a bunch of data. So we need voltage, resistance, and voltage, and amperage. Now obviously you can work these out from each other, so you don't necessarily need all of them, but I'm just sort of future-proofing it. For instance, where I just want to pass a single bit of information, just kind of removes a bit of math overhead having to do it at the time. Right, so if we do that, and then on here we can add a new variable, and this takes a while to work on this blueprint because there's like 700 instances of it in the world. So this is our fluid packet. This is our load report fluid packet, just to be specific. And that is one of them. Doesn't the voltage come from upstream, not downstream? Well, yes, but so in terms of the data flow, in order to have this performance and not constantly ticking, what we do is the end devices, so say the lights for example, they all report back to the cable. So it's like you can flag whether or not the cable is an end supply or not. So the cables come in two flavors. Either they're a point-to-point cable which connect two devices together, or they're an end supply cable, which is essentially the last mile with everything plugged into it. And what they do, so the cable itself is given a voltage, and that voltage is given to it by its source, and that sort of cascades down the line from the reactor. So each distribution box steps the voltage down more and more until you get to kind of the corridors where it's down to 240 volts. And then all of the things connected to that last cable, they tell it their wattage, which is derived from their own resistance. So we use the ohms value of that device, be it a light or whatever, to work out the wattage. And then what they do is they then report back along the cable what their wattage usage is. So then the actual transmission box, the distribution box, then knows the overall wattage that's being used. Now, what we also need to do with that is we need to, rather than directly reporting the wattage, we need to report resistance so that we can work out equivalent resistance on the main bus of the distribution box. And then it's the equivalent resistances that we're reporting backwards down the line. And then that's being used to calculate the wattage and the amperage and stuff. Yeah, so the data needs to flow backwards up the cable so the sending device can update its own UIs, because all the sending device knows is that it's sending out an X amount of voltage. It doesn't know what the wattage or the draw is on that cable until it hears back to know what either the resistance or the wattage is, so they can work out the amperage on that line. So that it's kind of unavoidable, really, that you need that two-way conversation. So the sending interface on the distribution box receives the report, which is what this load report is here. So this is basically the end device saying, this is what I'm using, which is why we're just, for the most part, just working with wattage, because it's just saying, right, you've given me this much voltage, this is my wattage, and then it takes that wattage value with the voltage and works out the amperage from there, because you can just calculate the amperage. But yes, I do want to transition to an equivalent resistance instead, which should be more true to life, I think, in the long run. Yeah, the only reason it needs the voltage is because of what updates the UI panel. So yeah, I think I see what you mean with that. So when we send the electrical packet out of the reactor's bus, it's not updating this UI. This UI is updated by the cable, so that the cable reports back to say what its usage is, including how much voltage it's been given. That might seem a bit backwards, but it allows us to keep everything in one place. So if I had the reactor bus updating this voltage on this UI, and then the cable updating the wattage on this UI, then we've got this UI being updated from two different locations, which just gets confusing. So it's easier just to update the cable, and then for the cable to go, yeah, this is my data, and then it just updates the UI, because we can then include things like error messages. So if the cable has a short, then it can report back, I've got an error, and then the error can flash up on the UI. Yeah, it's just kind of, I'm doing it to avoid having to update the same UI from two different locations. I think that's basically why I did it that way, because as long as the cable is the ground truth, I know that all the UIs are accurate. I guess it's also the cable that's going to have the most effect on the world. So it's the cables that are going to be damaged for the most part. So it's them that need to be updating the UIs. Yep, so this stream, I've got this one set to stay live, I think. Yeah, I've got the DVR thing turned on, so this stream and its chat will exist forever. So the load report is literally just for the UIs. It doesn't do anything else. No, actually, no, that is a lie, because we also needed to calculate the amperage. Yeah, sorry, it does also do that. So I've lost it now. Where is it gone? Is it that one? Yeah. So taking this one as an example, because this is the future of how I'm going to do all of them, where you've got an internal bus on, say, a distribution box, and then you've got the cable data that's reported into the box. So the internal bus is applying a voltage to the cable, so it doesn't update this UI. So it says to the cable, right, I'm giving you, say, 1 kilovolt, and the cable goes thanks and passes that along to the next downstream device. Now when it reaches the end, we then get the load report that goes back up along the cable in the upstream direction, updating all the UIs as it goes. And then when it reaches the internal bus, because then it sends that backwards to report what the current wattage is, current draw, so that this can update its UI, knowing what's actually what's being used. So this UI does receive updates from multiple sources, because you've got the information from the wattage coming in from it comes up the output, and that's where it gets confusing, because you've got things coming in the wrong direction, but it also receives its voltage from its source. So so the voltage data will always come from wherever it gets its voltage from, and the load data will always come from wherever the load comes from, which is the output. And that's how all of them will work on all of the electrical UIs, so that we've got this distinction between the internal bus and the actual cables themselves. Because obviously the cables are going to have a higher amperage than the internal bus, to some small degree, obviously, because the cables are going to have a higher resistance than the internal bus, which is essentially just a bus bar. Right, so we know that's working now. So, right, so on the cable then, so what we're doing with this, so rather than using this variable here, instead we're going to use our new struct. So that needs to be a rep notify, because we're going to replicate that and steal that. Event graph, there we go. Right, so this one is going to do this. Nice and simple. So all that's going to do is, when the struct is updated, it's going to replicate that on the network, so that all clients know that that's happening, so the client UIs will be updated as well. Otherwise you get this mismatch. Right, so then we can split that. Did I literally set the wrong... Oh, look at that, I did. Why on earth did I type fluid? I think it's because I've been typing fluid packet for the past month. That's better. And that is also an electrical packet, not a fluid packet. And then that needs to be rep notified. Actually, that's an annoyance of mine with Unreal Engine. If you've got a rep notify function associated with a variable, and you rename the variable, it doesn't automatically rename the function. And furthermore, if you do then rename the function, it still won't call it, because they're not connected anymore. It's a little thing, but it annoys me. Right, so voltage, resistance, wattage. And I may as well, just for consistency's sake, stick the amperage on there as well. Now it doesn't matter if we're not actually using these inputs. I'm just putting them there sort of as a just in case. Again, there's a lot using this interface, so it takes a while to compile. A long while. It would be much quicker if I had a test level with all of this stuff in it with just a few instances, but there's so much to set up with all the interface names and everything. It's a bit of a false economy because it takes so long to cable it all up. You may as well just do it in the live level. Okay, right, now we've got amperage. Okay, so now that we've got all that in a struct, when it comes to sending the load report down the line, all we need to do is pull in our struct like that, and I may as well use the same one for both. Okay, so we've now got all of that data that we need contained within a single variable that's replicated, which we can then just pass around whether we need it or not right now. So we don't need that anymore. Okay. Yeah, so it's more a case of just storing each of the values, or rather passing along each of the values separately, because depending on where the cable's used, there might be instances where I just want to pass along the amperage without having to recalculate the amperage. Yeah, so it's basically it's bidirectional. So we receive voltage from the upstream device. So the sending device sends us some voltage, which we then replicate and we send into the cable. And we perform any actions we need to perform on that, and then just send it along its way. And then in the opposite direction, we're then passing usage data essentially back up the cable. Yeah, so it's kind of like supply and usage, because all we're supplying is voltage. So the reactor is putting voltage on the wire, and then devices are then obviously incurring wattage by reducing resistance between the wires, incurring amperage, etc. I think I've got a handle on the electrical engineering side of things, but I'm still not completely there. You know, there are still aspects of the electrical engineering which catch me out. Like the value VA. I can't remember what that's called now. Quick Google a minute. Volt amperes, that's it. So the notion of volt amperes, which really is what the reactor needs to be reporting as its output, rather than just a voltage, because it's volts. It's voltage along with its maximum amperage. So the capability of the reactor should be expressed in these volt amperes. And I haven't quite got my head around that yet. For now, just for the tutorial, we'll leave it as volts. Okay, so on the reactor then, so we're now getting a whole stack of stuff coming through. See, that's the thing that confuses me. So if a volt amp is just a watt, because it's that whole potential energy thing, isn't it? It's like, so the reactor, at a quantum physics level, the reactor is generating charge by pushing against the electrical, so the magnetic field of the coils. So the coils are pushing in on the plasma, and then the fusion reaction is pushing back on those magnetic fields, which is creating the electrical charge, electrical energy. But then how do you define what that energy is? I mean, is that just voltage in its purest form? Because voltage is an electrical potential, not necessarily a power. So I think that's the bit where I get confused. I should probably take an electrical engineering course, really. I watched a video the other day, actually, where a guy was showing how resistors work, and again using water, but he had a really thin a thin area, can't think of the word for water, and he was putting metal bars in it to restrict the flow, and you could see how you had this like diagonal line as the water was flowing down, which is kind of an example of voltage and how voltage goes down as you go along the circuit. It's fascinating, actually. I was just going to see whether I could find it real quick, but it's like 1 billion videos on comparing electricity to water. It did make sense though. It was seeing the way that water levels off when you restrict the flow, and how that's sort of analogous to a resistor. It was interesting to see it visually. Yeah, I think the last piece of the puzzle for the electrical system is that equivalent resistance. You know, once we're calculating and passing equivalent resistance down the line, I think that is then a full electrical system. I don't think there's anything else beyond that we would need to calculate. so here, so on the load updates, oh, see, that's interesting as well, because that should not be updated from there. Because again, we don't want, or do we want? No, we do. No. We do want that because that's the inbound from the cable. So yes, we do want that to update the UI. Yeah, I'll leave that as is for now. But these ones do need updating, so we shouldn't get anything coming back on that one, because that's handled inbound, which is probably why they're not hooked up to anything, because they're not actually doing anything, so they shouldn't even need to be there, to be honest. So can we use the shuttle bay as a transition for planets? I mean, yes, we could, but I want to have that flight down to the planet rather than just teleporting straight there from the shuttle bay, because the shuttle bay is going to be used for more than just planets. So when it comes to alien stations and alien derelicts or anything else in the galaxy that you can get out and walk around on, the idea is that you'll fly a shuttle over to it, because the main ship itself won't be docking with things. You'll be using the shuttle to go across to those things. So the shuttle needs to be able to leave the ship and then have complete freedom of movement around space. So the shuttle and the ship are essentially two entirely separate craft. So you could fly them off in separate directions, or you could literally have someone on the shuttle and then the main ship just warps off into the next system, and that shuttle's still there in the previous system, just tooling around on its own. Yeah, so the idea is that we really want everything to be simulated as much as we can and as one-to-one as we possibly can. So yeah, so the only transition that we want is the surface transition. Yeah, we're going to avoid anything like teleportation or transporters, mostly because we're trying to base everything on real-world science, and everything I've ever seen or read on sort of teleportation technologies make it entirely impossible. That there's not even any theoretical physics that support teleportation being a thing. Will there be ground fault interrupts? Maybe not directly. So right now the planned fault conditions are a short, a break. I mean, I suppose we could, as part of a short, maybe have the cable sort of touching the framework of the ship and grounding out that way. It's difficult because there technically isn't a ground because you're in space. So, that electrical energy is just going to be going into the structural framework of the ship. But yeah, the circuit breakers will reset. definitely. So they'll trip, and you'll have to physically go and press the button to reset them. So say there's a sort of a hard short on the cable. As soon as the amperage breaks that trigger point, the breaker will blow. Yeah, so the way we're planning on doing the shuttles is the same as we do for the main ship. So in order to have full physics within the shuttle interior, especially if we had reasonably big shuttles, like some of them are going to have like sleeping quarters and things. You need to be able to walk around the shuttle, pick up objects, put them down. And because Unreal doesn't have variable gravity direction, you always only have sort of -1 on the z-axis. That's the only gravity direction we have available to us. So if the ship moves, then everything around it falls around. So the actual interior of the shuttle needs to be static, a static environment in the world. So when you walk through the entranceway into the shuttle, you'll actually be walking through a portal, same as the game portal. So it will actually be sending you to a static environment, and then the shuttle that you see flying around is actually a proxy for the shuttle you're actually in, which won't be moving. Same as the main ship. So if a player in a shuttle sees the ship flying past, they're seeing a proxy of that ship, not the ship that the people on the inside see. It'll have the same level of detail, it's just it won't have an interior if you're not in it. I'm not sure how they're doing it on the Orville these days, but it used to be the case that when you got in the shuttle, you could just fly it around as an actor, but it was attached to the same physical environment that the main ship was attached to. So if you rolled the Orville, then the shuttle gets dragged along with it. And I think they did make a change after that, where transitioning out of the shuttle bay was a loading screen, which we do want to avoid if possible, because we want that, that experience of coming in through the shuttle bay and landing and then getting out seamlessly, rather than hitting a loading screen as you exit the shuttle bay, which wouldn't be ideal. Okay, so this variable here, I'm going to repurpose this one. So let's just see where we're using it. So yeah, it's being used practically nowhere. So if we change that to electrical port, oops, that one. And that then is interface 1, electrical report. He literally just renamed the wrong one. better. Actually, I think we may have just broken the rep notify on that one. Let me just undo that. So yeah, there we go. Let's fix that. Right, so that needs to be notify again. That's no longer needed. And then we can just plug in all those values. Right, now we've got that stored somewhere central. Right, then we can just update the widget with that. Okay, so we got wattage and voltage in the wrong order. So hopefully that is enough information for it. Yeah, there'll be a slightly more smoke and mirrors than Half-Life. Again, because we can't simulate physics in the vehicle. The vehicle itself that you're physically in has to be static. Right, let's just make sure that that's actually doing some work on the calculating side. So it's going blah 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 blah. Yeah, so it's automatically working out the amperage for the UI. Right, let's see what that actually says. I'm going to have to go and compile a few of those blueprints, which is why it's taking so long. When you update a blueprint interface, any blueprint that uses that interface just needs a quick recompile. Interesting. Okay, we know that why that one's not working. It's because that's not on. be any draw on it yet because the reactor's not actually using voltage. That one, once again, isn't updating. Yeah, so on the fluid system, it is literally just passing it along, so it's definitely working the same way. So getting the data. Oh, look, that's what's the problem. Derp. Forgot to tell it to actually pass it along. So yeah, water is going to be implemented. So there'll be a full life support room. So you'll have the oxygen generation, which will use seawater essentially, which will be harvesting from whatever planet has salty water on it. Then you will have the wastewater recycling as well as part of the overall life support room. And I think it was Smarter Every Day that did a really good video on how submarines do CO2 scrubbing. I can't remember the name of the chemical now, but essentially it absorbs the carbon dioxide, and when you heat it up, it kind of expels into a gas, which you can then just vent into space. So it's reusable, so you can just kind of continually heat and chill this chemical to continually clean the air, which is really, really good. So we'll be doing that. But yeah, there'll be a whole room dedicated to all that kind of stuff. And yeah, so 3D printing is going to be how we do all of the repairs and maintenance. Okay, good, so we're back to that working again. Not sure why it's not reporting a voltage. I imagine that's probably at the other end. But obviously it needs the voltage to be able to calculate the amps. Okay, we have progress. Yeah, I think that's the problem. So essentially we're not sticking voltage into the report as it works backwards, which means this guy basically isn't doing that. So that will be part of the master distributor code. These things are monsters. So there's errors, blah 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 blah. No, we don't want that. We want this one. Yeah, it's the same deal essentially with these. We need to. These are going to need converting into structs so that we can pass back more data than just the load. Because when the system was first made, we only need to report the wattage. That's all it cared about. But obviously since then it's evolved a little bit, and now we need more data. Yeah, actually, the cable does have, it does know what its voltage is. So, where are we? Yeah, so we're setting the voltage here already. So, yeah, you make a good point, actually. Let's just use what we've already got. It should be that one. Yeah, that should do the trick. Yeah, you're right, because essentially we want the UIs to display information about like only the cable that's connected. So it's the details of that specific cable that we want the UIs to reflect. So this cable's voltage is, of course, what we want to know. I will go ahead and update all of these anyway to structs at some point, because it just having a struct with the ability to add information to it at some point is just, it helps future-proof the system. So if I suddenly need to add something more, maybe some, I don't know, weird alien virus or something that I need to suddenly start talking about across the system, I can just add it as an extra variable without having to redo the whole thing. But yeah, for now, that should actually do the trick. Let's just test it just to be sure. I guess the other point about voltage, of course, is that we're stepping down voltage as we go throughout the system, so that would be meaningless to report that backwards anyway. There we go. So the reactor bus now also needs visibility of the actual load on that wire, because it's directly relevant to the bus. Yeah, that's I guess when the voltage is so high, the amperage is teeny, but then we don't have like the main systems over here. These are going to be, huge wattage systems. We don't have them turned on yet, so that's going to obviously change. That's literally just all the lights on the ship. Right, okay, so let's hook that up to the internal bus then. So... no, we don't need a valve, we need a reactor. Okay. Okay, so the next thing we need to do is we need to pass that load to the bus, which means the bus is going to need its own load report. Does it have one already? No. Ah, that's good to know. My plan this week is I'm going to put a test build out sometime this evening with all this new stuff that we're working on. And I'm away at PitCon on Friday. So really, if I want to get this build out live on the demo, I need to do so sort of Thursday evening at the latest. So if I can get a test build out, like a finalized test build by Wednesday evening, that gives us all of Thursday to test it. Okay, so we're just going to pass the values on here. So right now we've got text chat within the game, and you've got either ship-wide broadcast or departmental broadcast. There's no reason why we couldn't make that even more granular and maybe have specific rooms. All the rooms will have their own unique ID, so we could potentially have a call feature so that you could sort of hail a particular room. It's definitely doable in text. Once we implement voice over IP, we can do it with that too. I also quite using the World of Warcraft approach, if you've ever played that, where you've got sort of /say, where only people immediately around you can hear you, and then like /yell, which you can be heard further away, and then of course then you've got the global broadcast. So like the cable, we only want to pass the wattage back. We don't want the voltage because we've already got the voltage on the main bus. So reactor bus voltage. Right, so that should give us a draw. Yeah, well, I've been looking at 11 labs for text-to-speech. They really are exceptionally good. I mean, it's in some cases really indistinguishable from a real person. But there is a cost overhead with that. They don't do it for free, and we're going to need to look at the cost of real-time text-to-speech. I mean, we can do local text-to-speech. But then you get pretty horrific computerized voices. As a stopgap measure, as an accessibility thing, then yeah, we can definitely try that. I suppose accessibility-wise, the other thing we can do is try and have some form of sort of audible feedback on the UIs, like a screen reader almost. Oh, that didn't work. Oh, I know I did wrong. I left it as 1, didn't I? Let's make sure that I've got the right ID. Yeah, reactor bus. I used to work with a lady who was fully blind, and she had like a Braille screen reader, which was amazing. You could hear it like clicking away all day. Now I still don't quite fathom how it worked, but it essentially did real-time Braille that she'd run her finger along. But she had quite a sophisticated screen reader as well. It was amazing just how well it could pick apart a screen and verbalize what was there. Right, okay, so internal bus is working, the feed's working, that's going to always show 0 until we put a load on it, which we're not going to have yet. So there's an interesting electrical conundrum. I guess this is going to have to be a combined draw, because obviously you've got the reactor itself applying a load, and then you've got the feed cable applying a load. So those two loads need to be combined for the total load. And then that also needs to be bound to this cable as well, because that's feeding this. This is where the startup sequence is going to have to be carefully managed, because this breaker is going to blow if you try and connect the whole ship to the reactor bus whilst the startup feed is connected. So really you're going to have to disconnect this one before connecting this one, otherwise this one's going to have like the full wattage draw straight down into the star capacitors, which sounds explosive. So all we need to do for this one then is we need to report back along there what we're currently using on here. Right, okay, that's the next step in the process. Right, okay, so let's get rid of some of these a minute. Right. So we're updating the load on the cable, which in turn updates the load on the reactor bus. Right, which in turn... Right, so that also needs to put the load on the cable. I think simplicity wise I might just stick that on the reactor's tick. So this is the kind of the main looping logic which is going on inside the reactor right now. Still tweaking it, so I haven't commented it all yet. Right, so why don't we move that out of the way a minute? So every time the reactor ticks, we need to take the reactor bus report, which we set that actually with the reactor's actual voltage. Yep. One. Right, so I'll leave that like that so I don't confuse myself. Right, so we're now storing that. Although, that having been said, I will keep them separate because that's actually updated more often. So that's going to be more in more real-time value if I take that directly. Which also means so rather than updating that there, we do it here instead. Because its load is coming from here, so yes, we don't actually need that saying that, do we? Because it's got its own voltage. So actually all we need from here is just break that, save using everything. So all we actually want is the wattage. Okay, so we're taking the voltage that we're already storing, adding the wattage from the bus. It'll work out its own amperage, so that should probably give us a massive amperage, because I don't think that was as high as the other one. So whatever the voltage is set on this side, which I might need to adjust. Obviously that's coming straight from capacitors, so it can be quite high. I think you would actually avoid a short circuit because you can't have, like if you switch, you can't have them both open at the same time. It's an either-or scenario, so it'll make more sense when I fix the wiring diagram. But the reactor starts only connects to there. So when that breaker is on, this is no longer connected to anything. Yeah, so although they're both connected to the same bus, they don't connect to each other. So this feed goes to the main bus, and this one comes from the main bus. But so interface 1 on the reactor is this cable here, which goes into this breaker here. But this cable and this breaker are physically separate from this cable and this breaker, so these two can't meet. Yes, because of this. So if you've got the start capacitors connected, the main breaker out is disconnected, and if you connect the main breaker out, it disconnects the start capacitors. So unless I'm missing something, that prevents a short circuit. So this one up here at the top left, this is literally just to supply this, so this cable and this breaker to be able to start up the reactor. Once you switch that over, this one is actually no longer connected. Because the reactor powers itself, so that actually shouldn't be showing any voltage, because if that is off, this shouldn't have any voltage on it. Yeah, so this one here, that's literally just for starting up the reactor. So under normal operations, that's off. These ones here, these are all the main high voltage feeds, and these ones all connect to this breaker here. So that's the main reactor feed. So none of these should be able to work whilst this one here is connected. All of these ones along the right hand side here, these are just the 2 engineering decks. So this is all the quadrant distributors. So that's these ones over here. Yeah, so essentially this starts up these, and then once the main reactor feed is connected, these and this are no longer supplied with voltage, because they're all being supplied with the main reactor. Yeah, it'll make more sense once I've done the wiring diagram. I mean, I originally, and I think perhaps it might make sense to do this at some point, is this was going to be 2 different boxes. So we'd have like the startup supply with all of its interfaces on one device, and and then the output on a separate device. But because of space constraints, I just put it all on the same device with logical partitioning. So yeah, we'd have to have two boxes physically next to each other. Visually, that would make a lot more sense. But if you think on it in the sense that this and this are two completely separate internal buses. Yeah, the only reason this one's over here is literally just, again, space requirements. I'd have to make the UI really, really tall. But that said, these are all changing to be like these without an inbuilt display like those. And again, on the UI, like with the reactor, you'll actually be able to see the internal bus diagram. So they all have their own internal bus. So essentially, you've got two separate internal buses on here. One for the startup sequence. So like that. So basically, we've now switched on to the startup bus, which is why everything's gone into emergency power mode. So this is literally only powering two engineering decks and giving it enough power just to get the reactor started. And once the reactor's running and self-powering, we then switch it over to the main bus and everything's then powered properly. It needs tweaking, definitely. I might need to make this its own separate distribution box rather than trying to make it generic like all the others. I've tried to do it so I've only got one actual class handling all of the distribution boxes, just for management's sake. It's easier to just update one class than two, but because this is so unique, it might need to be its own class, or as you say, have two separate boxes. Yeah, and YouTube's coming up with an error actually. YouTube is not receiving enough video to maintain smooth streaming. I'm not sure why. The main bus breakers in the current demo version, you can connect more than one breaker by selecting two breakers quickly. Oh, that's interesting. Oh yeah, so you can. Ooh, that's a good bug. So, oh, I see. Right. Yeah, okay, so what I need to do is right now, when you select one, it obviously greys out the other one. So when you select one, I need to grey out all of them. And that'll stop you from being able to do that. Because if you just go beep beep, you can turn them both on. Oh, how I love bugs. Yeah, you're right, it does. Cool. I've just got a time warning from Claire, so I need to pop out in a sec. But before I do, I'm just going to turn off all the fluid supply just to make sure that all the error messages work. So helium off, helium-3 off, deuterium off. Reactor off. Now that's interesting, actually. So ignore the fact that it still looks like it's on. It's not actually on. So if I connect that, just to turn the UI panel back on, it doesn't. Oh, interesting. Okay. This UI panel is quite tricksy because it does actually have a connection to this feed here, so the reactor room hardware, which is currently powered from the batteries, but is showing no load. Interesting. Yeah, so in here, this is the cryo room. So we've got our various different fuel tanks and all the support hardware for refueling those tanks, which is what all this stuff is here. So you've got our cryo coolers and all the input cables for those. The tank display there. Remember to wear PPE, people. Oh, the floor's not finished yet either. That still needs doing. And around here, these steps need finishing as well. So just those last few steps just need modelling, and then they should be all done. And then this floor up here needs doing as well. Yeah, so that's the cryo storage room. Okay, well, I think with Claire frantically waving at me and the advent of even more bugs, I shall pop out for a bit and then get back to that. So thank you for watching, everyone. And I think this is actually our first public YouTube stream, so more to come in the future, absolutely. And hopefully they'll get a little bit more professional as well. I'm just kind of winging it at the moment. But yes, so let's click some buttons. There we go. So thanks for watching, everyone, and I shall catch you on the next stream.